So, looking at the quiz, number 17. So number 17. Something like this. They do have an axis line through it. Pretend that's through the center. We're given that this is 2 inches here. That this is 2.83 inches. And from here up to the center line is 1.0 inches. And what we're asked for is how far up here. Now the way this is drawn, this looks almost impossible to find. But if we move some things, like I'm going to take this line here and I'm going to move it. Put it right there. What that gives me here is a triangle. Just like that. And it's a right triangle because that's straight up and down. Then if I take this line right here, which is the 2 inches, and I move that over, again, I get a triangle. And it's a right triangle because that's straight up and down. So what I now have are 2 similar triangles. I know that this dimension here, this dimension here is this is 1.0. And this is x, this is 2.83, and this is 2. And now we can find x by doing what? This triangle is similar to that one, just an enlargement of it. So 1 became 2.83 after the enlargement. X becomes 2.0. Cross multiply and divide. So that's one trick with dealing with the geometry like this, the similar figures, is being able to move sides and create those similar triangles. In our trigonometry, we're going to have to be able to do that a lot as well. Move those sides and create right triangles whenever possible. Do you want a second to finish that one off? Okay. Any others you want me to look at? $14. How about I'm going to do one very similar to number 14. We're asked for the size of that last pulley. Okay. So let's say this one has a radius of 8, and it is running at, let's put it at 720 RPM. We're going to have it come in here to one that has a radius of, let's go 3. In a dual pulley situation with this one here with a radius of 10. So let's see. Let's say that this pulley here is moving at 3,200 RPM. I want to know what's the, I asked for diameter of that pulley. So first thing you need to notice, all of these are radii, right? I'm given the radius of each of those. So when I get to the end, what I find is going to be the radius. I'm going to have to make sure I double it to get a diameter. So I got to be careful with that. So I'm going to start out. I need to know, is this direct or an inverse relationship? As the size of the pulley gets larger, does the RPM get larger or smaller? Smaller. So this is inverse, which means we're not going to do a proportion, we're going to do a product. So it's the size of the pulley, 8 inches, times the RPM, 720 RPMs. Equals, what do we know on the other side of this? Do we know the size of what pulley is it attached to with the belt? Attached to a 3. So we know the size is 3. X is going to be our RPMs there. So it's going to be 8 times 720 divided by 3 will give us what? 1920. So what that's saying is there's 1920 RPM here. How fast is the 10-inch pulley spinning? 1920, because they're attached to each other. They're on a shaft. On the same shaft where they're joined pulleys, either way, they have to turn the same RPM. This rule, this relationship, only applies if they're connected with a belt. So now the 10-inch pulley is at 1920 RPMs. Over here now, we're looking for the diameter, but it's going to be the radius that we're going to find, because 10 is radius. So I'm just going to call that Y for now, times 3200 RPM. So that size Y is going to be 10 times 1920 divided by 3200. Giving me 6. 6 equals Y. So the radius is 6. The diameter is 12. 6 times 2. Make sense? Okay. Do you guys need a couple minutes to finish up on the quiz? Just to take a look. So what I'm going to do is I'm just going to give you a couple minutes to look through the quiz, see if you have any other questions. And this one is a 1-to-1. This is similar to number 10, of course. If you have a 1-to-1, and this is kind of a mirror image. I drew it backwards for some reason. I don't know why. The key here is if this is 1-to-1, the radius of this ball is going to be the reciprocal of that. Well, the opposite of 1-to-1 is 1-to-1. The reciprocal of 1-to-1. And whatever the radius of this ball is, we'll just use the radius. This is a 250, so this radius is 125, right? So now what we have is we have that triangle, 125 thousandths here. These are going to be the same because it's 1-to-1. So those would be A and A. The key to this is that this is the aspect ratio. I just completed the triangle by drawing in that hypotenuse, the 1-to-1. This length here is going to be the square root of 1 squared plus 1 squared, which comes out to 1.414. And now you can find the dimension A and A, because 0.125 over 1.414 equals A over 1. Cross multiply and divide to find A. So once you have those dimensions A here and here, you can use it to figure out the total distance from here to here, right? You know this distance, so I can give you this distance here. Once you know this distance here, since it's 1-to-1, that's the same as this height up to the point of intersection. Then you're just going to add that height plus this height to get to the center, plus the radius to get to the top, gives you the total height. Any other questions? Well, with that, I want you to take a peek at, we're going to do like number 54 and 56 out of our packet. Problem number 54, this is in the packet now and not in the quiz. Hopefully I didn't go up to 54 in the quiz, huh? The gear ratio of teeth in gear A to gear B. is 5 to 1. What that means is gear A has 5 times as many teeth as gear B. If gear A is turning at 1200 RPM, what's gear B turning at? Now, a lot of people will just punch in numbers and they'll come with 240 RPM. That's not right. This is not a direct proportion. It's inverse. The point I wanted to make with this problem in 56 is very much the same, is that we don't need to know the number of teeth. All we need to know is the ratio of teeth. Because it doesn't matter if this, gear A had 70 teeth, gear B would have 14. It's a 5 to 1 ratio. So we can take 5 teeth for gear A times its 1200 RPMs equals 1 tooth for gear B times its RPM. It's going to work out the same. We multiply here and then divide by 1, we're going to get 6,000. So gear B has to be turning 6,000 RPM. One-fifth the teeth, 5 times the RPM. So number 56 works just the opposite. It tells you gear B turns 7 times for every turn of gear A. So gear B turns 7 times more. It must have 1/7 the number of teeth or 1/7 the radius if it's a pulley. That one appears to be a pulley, so it'll have 1/7 the radius. So that one's actually going to be just over a 1/2 inch radius. It's going to be a small pulley. So now, going down through here, there's several of them that are similar to that rather than having the pictures drawn out. Number 61 is slightly different. We talked about ones like this. Here, number 61, we have a pump. But again, does a bigger pump take more time or less time? Less time. So the pump size gets bigger, the time gets smaller. Again, an inverse relationship. Faster pump, less time. So for number 61, we have a pump discharging 6 gallons of water per minute, fills the tank in 30 hours. So 6 gallons of water per minute times 30. Notice the units don't match up here. I technically should change that 30 into minutes. But remember, we're dealing with ratios here. In ratios, the units cancel out. So as long as, if that 30 is in hours, as long as what we put over on the other side is hours, we're okay. So 6 times 30. How long does it take a pump discharging 20 gallons per minute? So 20 times X, where X is going to be the time in hours, because 30 is in hours. So 6 times 30 is 180. Divided by 20 is 90. Oops. 9, sorry, not 99 hours. Makes sense. That pump is more than 3 times as big, because it's actually 3 1/3 times the size of the 6 gallon per minute pump. Should take less than 1/3 of the time. Oh, let's see. These are all pretty standard then until we get up to some mechanical advantage ones. Like number 69 is mechanical advantage. Is anybody familiar with the term mechanical advantage? Okay. Mechanical advantage is output force to input force. Like a block and tackle, a lever. There's all sorts of things where you can lift more than what you can actually lift. For example, let's say that I have a lever here. It might be very possible for me to lift a weight with this of like 600 pounds. Can I actually lift 600 pounds? No. Is there any way I can exert a force of 600 pounds on here? Not unless I have a buddy and we weigh 600 pounds together, right? But let's say that I'm standing here pushing down on this, and I can exert a force of 150 pounds downward. I can do this because of the mechanics of how a lever works, of how simple machines work. I'm putting out 600 pounds, I'm only putting in 150 pounds. That's a 4-to-1 mechanical advantage. Now, one basic law of science and physics and the universe is you can't get out more work than what you put in, right? But work is a combination of two things. It is a force, but it's times a distance. So the amount of force that was put out gets larger. What must happen to the distance? It must get smaller. So let's say I'm going to lift this 8 inches. How far do you think I'm going to have to push down here? Well, the force was multiplied by 4. The distance is going to be divided by 4. I have to push 32 inches here because it's force times distance. 150 times 32 is 4,800. 600 times 8 is 4,800. I get the same total work on each side. That would actually be inch pounds, so technically I should convert it to feet to get foot pounds. It would be a more practical unit of work. Or with a pulley system. A single pulley has a mechanical advantage of 0, by the way. Let's say I'm pulling on this, trying to lift that weight. If I pull on this, let's say I pull 3 feet, how far is the weight going to move? 3 feet. If this is 200 pounds, how much force do I have to put on this? 200 pounds. Has a mechanical advantage of 1. It doesn't change. All it changes is the direction, which can be beneficial. This allows me to just grab onto it and use my weight. So there's no benefit to it. There's no mechanical advantage to it. Here, though, with 2 pulleys, now if there's a weight hanging on here, let's say this is 200 pounds. You think about it. If I move this 4 feet, is this going to move 4 feet? No, this total rope's going to get 4 feet shorter, but it's going to be 2 feet on each side, right? So this is only going to move 2 feet higher. So what does that say about the force I have to put in here? Half. I'm going to put in 100 pounds. I'm moving twice as far. I only put in half the weight, half the force. So that's mechanical advantage. In a lever, that distance, mechanical advantage can be calculated by distance from the fulcrum, the pivot point. This is what we call a fulcrum. That's where the lever pivots. So let's say that the weight I am lifting, let's say I have let's go 300-pound weight here. And let's say that it is 2 feet from that fulcrum, where that weight sits. And you go from that fulcrum to where I'm going to push, let's say that is 6 feet. Anybody want to guess what my mechanical advantage is going to be? Yep, 6/2 or 3-to-1. So how much force am I going to have to put in here? It's going to be 3-to-1. It's going to be 100 pounds, yes. And the simple way to figure that out is if I label that as x here, that force, it's force times distance. X times 6 equals force times distance. What do you guys think? Good stuff?
So the 300-pound piece you're trying to move goes on top of the weight?
Yeah. Well, the 300-pound piece, yeah, that's the output force. If I was just making the ratio, that would go on the top of the mechanical advantage. But the key is, for mechanical advantage, it doesn't necessarily what the advantage is. It's always force times distance has to equal force times distance. The work has to be the same on both sides. The input work and the output work have to be the same. Okay, what this should enable you to do is this should enable you. Did I take out the electrical circuits? Looks like I did. I don't have any electricity. Oh, I do have electricity in here. You should be able to do now in the packet up to number 74. And also then 77 to 85. So skip 75, 76, and then tomorrow, or not tomorrow, Wednesday, we'll discuss 85, 86, or 75, 76, and then we'll discuss 86 on. We'll finish this, pack it up. Then we've got to be getting close to finishing up this unit. Let me take a peek here.
What's next unit about?
Next unit, we're going to do cutting speeds and stuff. Yes, we will be finishing up this unit, so we'll probably be having our unit test on Thursday. This is right here. No, just kidding.